Okay, 10.2, finding arc measures. Still the same standard, G.C.2. I understand and can apply theorems about circles. So, arc measure. Couple definitions we have to start with. First of all, a central angle is an angle whose vertex is the center of the circle. So, for example, I can outline a couple here. Center of the circle is F, so angle AFB. That would be one example. We could do BFD. We could do angle EFD. And then I'm just going to put in here, etc. There are a lot of different options we could go with there, but those are all examples of central angles. Okay, if you look at your circle and we go back to AFB, the one I outlined in blue, the measure of that angle is 110 degrees. If we look at the one that I did in red, BFD, the measure of that angle, well, you would have 70 plus 65, and then EFD, you would have 45 degrees. Minor arc. An arc that measures less than 180 degrees. Now, this is going to come later, but for example, if you're looking at the angle EFD, okay, that's the angle. Well, now I'm talking about the arc. So the arc that corresponds with that angle is right here, ED. Okay, so it's the part of the circle. So if the angle is 45 degrees, what we're going to learn here is that that arc is also 45 degrees, and we can name it. Okay, so a minor arc is an arc that measures less than 180 degrees, and they are named with 2 letters. Okay, so for example, the one I outlined over there is arc ED, and the way you denote an arc is you put a little like arc over it. Okay, and that is read as arc ED. And there's a lot of other examples of arcs on there. I'm just going to go with the one for now. Major arc. A major arc is an arc that measures more than 180 but less than 360. Okay, now a major arc is named with 3 letters. Okay, now without trying to make my picture too messy up here, there's a reason for that. So a major arc, we're trying to get more than 180 degrees. So let's say we went from A, F, D. Okay, well that's going to take me around this way, and my arc would be right there. Well, the reason, and this is very important, so tune in for a second, the reason we need 3 letters, for example, is I could say A, B, D, A, B, D. I could also say A, C, D. That's the same thing. It's because it actually tells you to go that direction. If I just told you AD, what's to keep you from going that way and just going from A to D? Well, that's the minor arc. So if I give you 2 letters, AD, that tells you minor arc, go the small way. Versus if I give you 3 letters, it's giving you, okay, wait a minute, you have to go from A to B, then D, so it maps out a larger arc and gives you direction to go, kind of like clockwise versus counterclockwise. Oh, and speaking of that, naming an arc doesn't always have to be clockwise or counterclockwise. You can name it any way you want. Semicircle. An arc that is exactly 180 degrees, which some of us know semicircle as half of a circle. Okay, and these guys are also named with 3 letters. Okay, and kind of for the same reason. If you're doing a semicircle, which is like half the circle, and you just tell me AC, well, did you want the left half of the circle or did you want the right half of the circle? I could go from ABC, which is the right half of the circle, or I could go AEC, which is the left half of the circle. So you have to give me that 3rd letter so I know which one you're talking about. So this is more of what I kind of started explaining all together. Measure of a minor arc is the measure of its central angle. The expression measure of AB is read as the measure of arc AB. Okay, and what it's telling you here is that if you have this central angle that's 50 degrees, well then the measure of the arc right here, AB, is also 50 degrees. They're the same. Measure of a major arc is the measure of the entire circle. Oh, sorry. The measure of the entire circle is 360 degrees. So the measure of the major arc is the difference of 360 and the measure of the related minor arc. And then it tells you that the measure of a semicircle is 180. So if I wanted the major arc, or the major angle, that corresponds over here. So ADB, ADB, you could just take everything, which is 360 degrees, subtract off the 50 degrees, and then I know that this green one is going to be 310 degrees. Last definition we're working with, similar circles theorem. So first of all, do you remember similar? Same shape, different size. That's the definition of similar. Okay, think about this for a minute. We're talking about circles. All circles. And the definition of similar is same shape, but different size. Okay, well, if you're talking about circles, what do you know about the shape of all circles? And I hope you're thinking in your head, they're all the same. But they're all different sizes, right? You can have a radius of 2, you can have a radius of 10, you can have a radius of 50. So all circles are the same shape, but different sizes. So guess what? The similar circles theorem, all, I repeat all. This is going to be a level 2 question and you better just know it. All circles are similar. Because they're all circles. They're all the same shape. They're just different sizes.